So another important concept involving solutions is what we call dilution. So if you are familiar with concentrated juice, I'm sure you can find these in supermarkets, okay? When you prepare an orange juice from an orange concentrate, you're actually performing dilution. So for example, look here at the label of this orange concentrate. So we have here a mix ratio. It says here 6+1. So it means that you need to add 6 parts of water to 1 part of your orange concentrate. Okay, so you are diluting it so that your throat won't burn down with the concentrated juice. So dilution is the process of preparing a less concentrated solution from a more concentrated one. So this is very practical. It's widely performed in chemistry experiments. Okay. So for example, suppose we want to prepare 1 liter of a 0.4 molar potassium permanganate solution from a solution of 1 molar potassium permanganate. Okay. So it already says here how we are supposed to do it. We must take 400 ml from the 1 molar potassium permanganate solution and dilute it to 1000 ml by adding water. So for you to be able to comprehend what these statements are saying, okay, let's say we have here 1 molar potassium permanganate. So this is 1 molar. Okay, now I want to prepare 1 liter of 0.4 molar potassium permanganate. Okay, so how am I supposed to do it? Okay, so it says there we must take 400 ml from this one. So I get another container. Okay, then I get 400 ml. So let's say it's around up to here. Okay, so I have now 400 ml of 1 molar potassium permanganate. So take note, the concentration doesn't change because I didn't add anything. Okay, I just took a certain part of the original solution. Okay, then you dilute it to 1000 ml by adding water. So essentially, I'm gonna add 600 ml water to this one, and then I end up with my 1 liter of 0.4 molar potassium permanganate. Okay, I hope you understood that. So there is actually a formula that you can use when you want to solve dilution problems. Okay, so recall in our previous situation or scenario, I got 400 ml, right, from the original solution and placed it into another beaker. Okay, then I added 600 ml of water to get my 1 liter 0.4 molar potassium permanganate. Now, okay, only the volume changed. The volume changed, right? But the moles of solute and before and after dilution didn't change at all, right? Okay, so let's go back to the definition of molarity. So molarity is moles of solute over liters of solution. So if I cross multiply this, I have moles equals molarity times volume. So if the moles of solute before dilution is equal to the moles of solute after dilution, I can make this equation, this type of equation, wherein this one is the molarity of the solution before adding water, and this is the volume of the solution before adding water. Then we have the final concentration. Sorry, this is supposed to be V. And then the final volume. So in our previous scenario, Okay. Our original concentration is 1 molar. Our final or desired concentration is 0.4 molar, and our final volume is 1 liter, right? So we need to determine how much of the 1 molar solution should we get. So applying the formula, so the I stands for initial and F stands for final. So we have 1 molar times VI equals 0.4 molar times 1 liter. And this will give us a value of 0.4 liter or 400 ml. That is why it says there we must take 400 ml from the 1 molar potassium permanganate solution. Okay, now we can move on to the types of solutions. So, solutions or solutes actually, solutes are described in terms of their solubilities. So solubility is the maximum amount of solute that can dissolve in the given amount of solvent. So this is where we apply the rule like dissolves like, which I will expound later on. Okay, so the types of solutions are determined based on their capacity to dissolve a given solute. So I'm sure you're familiar with these terms. We have the saturated solution, the unsaturated solution, and the supersaturated solution. So when we say the solution is saturated, it means the dissolved solute is equal to its solubility. So for example, let's say sodium chloride has a solubility of 50 grams per 100 ml of water at 25 degrees Celsius. So this is just an example. Okay, I'm not sure if the values are correct. And let's say in a container, so I have 100 ml of water and I added 50 grams of sodium chloride. So since what the amount I added is equal to the solubility or the maximum amount that this amount of water can handle. The maximum amount of sodium chloride that 100 ml of water can handle, quote unquote. This is a saturated solution. Okay? So what will you observe? So all of these 50 grams of sodium chloride will dissolve. So you will see a clear solution. Okay, now what if I added instead of 25 grams, I added instead of 50 grams, I added 25 grams of sodium chloride. Since it's less than the solubility, this solution is unsaturated. Okay, now let's consider a different scenario. 100 ml of water, and then let's say I put here 150 grams of sodium chloride. What do you think will happen? Okay, let's say this is at 25 degrees Celsius. What do you think will happen? Okay, 50 grams definitely will dissolve, right? Because it's equal to the solubility. And then we have here 100 grams, right? The excess. 100 grams of sodium chloride that will remain as solid. So what type of solution is this? This is still a saturated solution because the dissolved is equal to the solubility. It's 50 grams, okay? The 100 grams didn't dissolve. Okay, so this is still saturated. But what if I heated this, okay? I heated this, and in general, heating increases the solubility of some ionic compounds. So I heated this up to a certain temperature. Okay? Okay, I heated it up to a certain temperature, let's say 90 degrees. So all of 150 grams of sodium chloride dissolved. Okay. Now this one is not a supersaturated solution. Okay? Because for example, at 90 grams, the solubility of sodium chloride is 200 grams per 100 ml of water. So this is actually unsaturated, right? Now, next thing I will do is I will cool down this solution. Okay, so cool this back to 25 degrees Celsius, but we will avoid the excess, the 100 gram supposed to be excess sodium chloride. We will avoid its precipitation. Okay, we will avoid the excess 100 grams to go out of the solution to become a solid. Okay, so in the process, we reach 25 degrees Celsius with 150 grams of sodium chloride dissolved in 100 ml of water. This is your supersaturated solution. Okay, so your supersaturated solutions are very unstable. So if you just shake it a little bit, you agitate it, the excess 100 grams sodium chloride will start to crystallize. So you will see solids forming in your solution. Okay, so you definitely should watch the video that I will link. I will give the link so that you will see how that happens. Okay, so this molecular view of solutions, I have another video, I think I mentioned this before, a video that differentiates molecular solutes from ionic solutes. So please watch this video so you understand the difference between a glucose solute dissolving in water and sodium chloride dissolving in water.